Hello everyone. On today's tutorial we're going to learn how to create this effect that you see here, and it's all about fields and really how to control them and art direct them in order to achieve what we need to. We're going to create this custom field here, and if you notice we have two streams here. Some points are going this direction, some points are going this direction, and then also the points are basically avoiding these obstacles. So we're going to learn all that and how to create all that with fields. Um, Obviously, this is not a fluid sim or anything physical accurate, but it's a fun exercise to learn how field works. And then when you have this field, you can apply this into any other solver that you might want to. And you can do more to it as well. With that said, grab a cup of coffee and let's get started. Cheers! Hey everyone, so let's get started. Let's create a new graph here. I'm gonna delete the input and output. Let's create a plane, create mesh plane. I'll create a value from here just to control this with one value, and let's make it I don't know, 20, 25, whatever. And let's create a terminal now and output that so we can see. Let's hide the grid. All right, that looks fine. Let's scatter some points. Scatter points, and that's way too many, so let's go start with 15 and let's create instance. So this is gonna create instance for us, and you have a preview geometry there. And what I want to do with this actually is having no overlapping points. Basically, I want to try to avoid the overlapping, and you can try to get lucky here and change the seed and see if you can get lucky, but the easiest way is just to change the scatter mode from random to blue noise, and that will give you basically that. Let me create image spheres. We have that now, and what I want to do is grab these spheres and give them some noise, so it's not so just change a little bit the shape, right? So it's more randomized, not just so spherical. So for that, what I want to do is create a for each, and to keep this guy procedural, we're gonna actually grab the point from our scatter. So I'm gonna say get point count, and this is gonna give you the amount of point, how many points we have in the scatter. In this case, 15. I'm gonna connect that into the max iterations here. I'm gonna go inside. Oops, let me put this guy here, input that, and just pass the data. And what we want to do is, this is working obviously in the spheres. We have a max iteration, and just display these points I want to. I'm gonna create a noise, fractal turbulence field, and this is an auto port, so it's gonna support vectors, scalars, and the same with the weights. You can see when that when an array has a hat here, or kind of a hat, it means that's an auto port, so you can accept different type of data. And you can read that actually here too in the info node. If you go here, I will recommend reading this always if you don't know what exactly it does, but displacement vector. And this actually, as I said, this is an interpreter port, going to float, array floats, strings float, vector fields, and all that. And this is a vector right now, and this is gonna set floats. Anyway, so let's connect that, and I'm gonna now connect the for each into the instance geometry. And as you can see now, we're getting a noise, but it's all the same for the amount of points, right? So to vary that, just connect the current index into the seed, and as soon as you do that, now you can have a different seed of the noise per iteration. And obviously you can change this here to whatever you want. If you want to make it less fractal, go magnitude. This is going to give you a -1 to 1. Also, it's in the info tab what this outputs. So I just don't want negative numbers. You can clump it. We can clump it. We can. So I can just grab that, clump that, and then say, give me a value from 1 to 1. See which one. Another way you can do this too, which might be easier, just to put an F curve fill. And this basically also is going to give you a CH1 value here, 0 to 1. Cool, so let's keep it like that. And now we have different noise per iteration. I'm sorry, for the amount of points, right, for iteration. Cool. Next thing that I want to do, I want to just randomize some of the point properties that we have. So basically, we have some noise for that, like randomize, point rotation, scale, translation, and whatnot properties. I created my own, which is called just randomize properties here. And basically, this is just a higher level compound with all those noise that I mentioned. And I can go inside here and just see randomize rotation, scale, translation, geo. This is just a node that you can randomize for any property attribute that you want, and then also just create a randomized color here as well. If you want this, I can give it to you, but again, this is nothing really that advanced. It's just an utility that it's just easy for me to randomize a bunch of stuff here at the same time. So I'm just gonna randomize the rotation, and also I wanna randomize the scale here. So I'm gonna go 1, 2, maybe 3. That works, and definitely want more bigger shapes. So I'm just gonna grab the last one here and then make this guy something like that. We can play with this later too. That's the beauty of like a procedural system. So let me, now that I see this, there's too many points, so I'm gonna lower the point count here, maybe go 12, change the seed, and we can change this later anyway, so it doesn't really matter, just something pleasant. Okay, the next thing that we want to need to do is basically create a volume for this. So I'm gonna use the mesh to level set here again, because this is gonna give you an SDF directly, and it's a little bit cheaper than the other two nodes that we have. By default, these work with an absolute resolution. So I'm gonna actually change this to 0.01 and connect this into, well, actually, if you try to connect the instances directly into the mesh level set, this is not gonna work because we are dealing with instances. So that's gonna be basically kind of points. So this is not gonna do anything, just in case. So for that, what we need to do, we need to get the instances back to geometry. So for that, we have a node called bake instance geometry. So we get the points of the instances, and then we get the matches. And as soon as I do that, then we get an SDF. Great. By default, the mesh tool level say import all the properties, but I don't want these two, so I'm just gonna uncheck the asterisk, and then we're gonna get the sign distance, which is the only property that I really want. This is important, by the way, to transfer just attributes, properties that you need, not just for this. Probably for this it won't really matter if I import this, because it's not a large data set. But when you're dealing with millions of points or like a huge data set, start managing what kind of attribute you save actually in a cache, or you start transferring between operations, because that start adding up on the computational time. So just keep an eye on that. Just transfer what you need. It's just a good measure. All right. So we have the level set that we need, and the next thing that we will do is actually start creating our guide curves on this. So let me get back the plane actually. Connecting to the proxy, and now we don't need to see that. So just this, and did I connect that in the right spot? Actually, I need to connect it to elastics. All right. I'll go to the top view. You can create whatever you want here. I'll just create, let's say right click, create curves, EP. We're gonna go from positive C to negative. So let's go maybe with something like this. And then maybe I'm gonna press enter. Let's actually, I don't want to do that. I want to just make it go all the way there, so it's very, very obvious what we're doing with one of the directions. Move this guy right here and press Y to repeat the tool, and
For this one, we're gonna do a little bit more, yeah, something like that. Cool. All right, so we have the two curves that we're gonna use for our guided simulation. So I'm gonna just rename this and then saying curve A, just to keep it organized, and curve B, and then I'm gonna group them. I'm gonna call this Strands GRP group. Okay, cool. This is just for organization, that's it. So I'm gonna bring curve A and then curve B. Great. Let's go back to the perspective now, and what I'm gonna do, I'm gonna create a point scope here. I'm gonna merge these two just to show you a couple of things here. So fan in, right click, merge, merge. And let's disconnect this and let's use this terminal. Alright. I'll connect that here and that here. Let me change the background here as well. Let me change the color and make these points a little bit bigger. Actually, white is fine. Alright, so you can see the points that are in this curve. If I show you how these curves come into Bifrost, as you can see, they don't match what we see in Maya. And because the interpretation of the curve, you have different interpretation, linear sampling, CVs, or length. The length is going to give you basically the closest, and it's going to create a bunch of points, which actually you can actually resample if you want, or just change right here as well. You can match ends as well, as you can see there, or you can use CVs. By the way, it's going to be the same as whole. If you create here whole, now this is going to match my whole. Then you have segments, and if you give it more segments, also it's going to start matching more the curve that is coming. So it's going to interpret that curve a little bit more accurate. You can change this to even space as well. So actually I'll use this to match closer the curves. You can use any of the other options if you want to. But I just want to show you that if you see these, just make sure to go to the shape here or to the input node and then change to one from one of these options. So when I match this, it was 5, let's go 5. And actually then if you don't want to have that many points, you can always resample after the fact as well here. So if I resample this now, by default this is spatial, so the higher you go, the lower point count you can have, and the lower you go, the more points you can have. Or you can do a constant count, which is going to be, you're telling it, give me 20 points, it's going to give you 20 points. Obviously the lower you go, you're not going to match, so it's the same. But this is a little more controllable because you are telling it exactly how many points you want. We're not going to use that, but just in case that you didn't know how that works. So we have the curves, and they come with a few properties, and we have a property that is very interesting to us to do this, is this point tangent. Each curve that you have is going to have this point tangent. Sometimes they don't, and if they don't, you can use the update basis, strand basis, and basically this is going to update that, or if you do manipulation on the strands as well, you can always update this to give you more accurate, and that's going to output also a tangent. And what is a tangent? Well, we can preview this. So if I go back here and we say enable arrows, but it's looking for velocity again, so we're gonna change this to tangent. And if I make the points a little bit smaller now, let me hide the original curves here. You can see that we have this arrow pointing, basically that is pointing along this curve. So basically it's a vector that is gonna follow, in simple terms, it's a vector that is gonna follow this curve. And that actually is going to be beneficial to us because this is exactly what we need in order for these points basically to grab this tangent of the curve, and then in order for the points to follow this strand, right? And what we want to do basically is get this. I mean, we can just use this directly to convert into volume and SDF, but it's just more friendly if you get it. Get GeoProperty again to get that. It's going to be a vector. So if you make this a little bit bigger, it's going to tell you what kind of data type it is. And it's a vector, so I'm going to get it. Change this data type to vector3. And we're going to say point tangent. So now we have it here. Oops. Tangent. And we're gonna set it just to point velocity because that's what people is used to usually. So if you connect this here, get it, we can just set it that way. Now we have a new property called point velocity. All right, so as I said before too, there is another property that is actually pretty useful, but we are not gonna use, but I'm gonna just mention it very quickly, which is the point ratio. And that property I can show you right here. So say point ratio, let's do color property, and basically what this is going to give you is a normalized value from 0 in the start, right? Whoa, I think this is because I'm full screen here, from 0 to 1, and then it's going to be interpolating the values right here. And that actually is pretty useful because you can do a bunch of stuff. For example, if you want to extrude this strand, you can tell to use this the point size and manipulate this so it goes smaller and then start becoming bigger. Or if you, for example, scatter points in this strand, you can also use this value here to scale those points accordingly as well. So let me delete these frames. Sorry about this. That it's way bigger, but so that, and let me just now hide it. But again, we are not using it. It's just something that is super useful as well. Useful data to have. So what I'm going to do is just copy this again and do it in the other curve here. And actually, we're not going to use the merge, just to keep it a little more straight. We could, but there's no need. Okay, so what we need to do is now I'll delete this for a second here and just have these guys like this. So what I need to do now is convert this into an SDF, and for that we can use our trusty friend points from volume. Points to volume, and again by default it's going to be Fox. We need to change to an SDF. Absolutely is fine. I'm gonna copy and paste this guy here. Now if we look at this, one of these guys here, and let me just change the background here real quick. We have an SDF, and we can have a look here at the properties as well. And as I said before, we are transferring all these properties, which really we don't need. So I'm gonna just delete all of this. The only thing that we need here is just the tangent or the velocity, which is the same, and the SDF. So what I'm going to do is just delete all this and then just transfer point velocity. So now we have voxel velocity and the SDS by default. And instead of me copy and pasting, I'm going to copy this again here and then just grab that from there. Cool. So now we have the same thing in both and we have the same properties. Again, just to remind you, just passing the data with the data that we just need. There is no need to pass all the data. All right, cool. So we have that, and then what we need to do is convert this into a field. So I'm gonna say voxel field, and we have the SDF, copy paste, and also I'm gonna do some I'm gonna use right here as well, because we need the SDF here. Great. So let's keep going.
Okay, so we have our field set up. We got the SDF. Let me disconnect the scope here and then just leave it here. And what we need to also get from the volumes is the voxel velocity. So I'm gonna copy paste this guy here. I'm gonna say voxel velocity here. Also, I'm gonna type our parameters here, so I can say field underscore type, and also I'm gonna say property, so we can see what kind of data we're dealing here. This is the parameter, the name of the parameters, by the way. Also, I'm gonna just copy this here. Well, let's leave it like that, and I'm gonna say the same here. Oh, actually, before I do that, and then let me just do the same here. Actually, sorry. Copy, paste, and by default, when you create a new voxel field, it's gonna read the voxel. It's gonna have this voxel sign distance, and by default, it's a scalar field, which is correct. When you have a vector field, which is velocity in this case, still reading as a scalar field, so you need to make sure that you change the data type here to a vector field to correct this, to read this correctly. So Bifrost read this data correctly. So now it's a vector field, and you know the velocity is a vector. So now this is working correctly. I'll copy this guy here and paste it. I'm just connect it here. And just add it here to the property. So now that we have the velocity and the SDF, we can multiply these guys. So I'm gonna multiply my vector by my scalar, and to preview this, we can add create mesh plane, which also is going to be our source for the sim later on. So let's do this, and I'm gonna just make it around 30, and then also I'm gonna add more points here. Let's do 50 for now. Okay, and then I'm gonna create a vector field scope. Grab that here. And now, as you can see, let me actually unhide it. Strands again. We have the multiplication. I'm sorry, the field, and the result is the multiplication. Basically, as you can see, the SDF. We have lower values here, and this can be seen by this lower. Let me just hide this. By these blue things or blue values here that you see here. Actually, let me change the interpretation to. I want to see these. And then red means like a little bit higher value, so it's closest to the surface. That's why we're seeing that. So however, I want the reverse, so you can reverse fields in different ways. The easiest, or actually the more, you can say the F-curve field, or the more artistic way is with the F-curve field. And actually this is wrong, because we need to just to do it to the SDF, not to the result. And if I do this here now, as you can see, also this normalize this field, or the SDF, from 0 to 1, but we have the right value here. Well, actually we don't have it, we need to reverse it. And now we have the right value. So now, if I zoom out a little bit, we can play with the position of this, and then we can create a nice follow for this custom field. So I'm gonna leave it, I don't know, let's say 10 for now. Now we can change, again, this can all be changed later on. And let me move these guys here. I'm gonna just copy paste these guys. Copy paste. And I wanna have the velocity, the SDF here. And what I want to do is add these two fields. So I'm going to say add, right? And now you can see that this actually is adding the two fields together, and we have a nice transition between where the curves, actually the strands are, right? So you can see clearly where this velocity field is gonna go, and this other is following the strands basic direction. And then in the middle we have this kind of nice transition, the transition between the two fields. And if you want to change both F curves at the same time, let's just make a switch here. What we can do is just create a value from here, right? And then we can connect and we can play with this at both at the same time here. So it's up to you, obviously, but it's an option. And that is why also I wanted to separate this, because obviously you can merge and then do just this once. If you need it once, you can merge these curves and do that. This just give you more options basically to play with the F curve and all that stuff. So now that we have basically the field finished here, we can start testing it out in our simulations. And remember, this is a custom field, so you can play with this in we're gonna test it with particles, but you can go into Aero or npm or any other kind of simulation too. So okay, so let's do that.
All right, so let's create a particle. So I'm gonna say basic particle graph. I'm gonna explode this, right click explode, and I'll delete the collider. We are not gonna use that. And let's move some stuff around here to make a space with our field here and our scope. And what I'm gonna do, I'm gonna grab the plane, and that's gonna be actually my source for the particles. I'm gonna change this right away to 1001 since my timeline start that. I don't want to use any normal speed here, and I'm gonna turn off gravity. So if I press P to see the points here, I'm gonna turn off the field and then just press play. Nothing is gonna happen because obviously I don't have any influences. So I need to create a set influence property. Influence set property. And I'm gonna actually connect the field straight into the value and connect this guy into the influence and then just affect the point velocity. You can also do this in just set influence force, for example. So you can use either or. It's gonna work basically either or works. They're gonna both work a little bit different. I like to use velocity when I have more control over what I want to do. It's a little more art directable, but you can also use force if you want to. So now when that is connected, I have point velocity here now, and I press play. You will see that now the points are moving, basically obeying that field, as you can see. And also I don't want the particles to die after 2 seconds, so I'm gonna check this live forever. So as you can see now, particles are moving and they're being born and moving around, or actually following this tangent, and actually we have that fall off there in the middle as well, as you can see. As you can see, it's moving pretty slow, and that is because our field is also might be a little bit slow. So what I'm gonna do to speed this up a little bit, I'm gonna just multiply our velocity field here. So I'm gonna grab the add, I'm gonna create a scalar field. Let me press stop here and go here, and then add this here, and then we can just multiply by some kind of value. It can be whatever you want. Go back to the beginning, reset feedback port, and then just so you know, the reset feedback port is right here, the state, and that the shortcut Control R. That is context sensitive, so you need to press that inside the graph, and that is gonna work. So now if I press play, now you can see more obvious what's happening here, and that is working great. As you can see, when I press play, our frames per second are not great, and this is because our field that we have is being computed on each frame basically. And really, if you will look at the field, right, let me just turn off the points here, and you just press play, this is no animating at all. We don't have a noise, nothing. So really what we can do here is just compute this field once and then pass it to the particle. there is no need for us to compute this on each frame. That is just wasting resources of the computer, right? So for that we have a node called compute on frame, which is super useful. So if you connect this right here and you tell it which frame you want to pull this data on, so when I say on the first frame, and my first frame is 1001, look at the frames per second now. As soon as I press play now, let's look at the points again. Boom. We are basically real time, 24 frames per second, which is great. And this is because obviously we are just passing this on once. It's not calculating on each time on each frame time step, right? So that is a little quick thing. Obviously, if our field here is animated, you're gonna have to compute it on each frame. I mean, there is no, there's no way around that. You can always catch it if you want and then load it and then just pass it that way, but still it's going to be moving and it's going to be a little bit more of computational time there. All right, so this is working and it's working great. Now we have basically this is a little bit maybe too fast, but other than that it's working great. So I'm going to lower this and then Control R, and then we can move forward with our obstacles. So that's what we're gonna do next.